Good morning. First of all, I must apologize for not being able to be there today. Unfortunately, Madeline's still sick, and I gotta stay home and take care of her. You guys just finished talking about Newton's first law. And in Newton's first law, we talked about how objects in motion tend to stay in motion, objects at rest tend to stay at rest. Well, we need to move on and start talking about Newton's second law. And if I was there to show you some notes, I would show you just basically a slide that says what this here says here. According to Newton's second law, force equals mass times acceleration. Of course, Newton's second law is a little more wordy than that. It says that for a given force, the acceleration, or for a given object, force and acceleration are directly proportional. And mass and acceleration are, for a given force, mass and acceleration are inversely proportional. That just sets up the equation for us here, F equals ma. It's one of the really big deals in science. To sort of test this, we're going to do a lab, and in the lab, you can have a setup like this. I know the drawing's a little strange when you look at it first, but you got a Pasco track, and you're going to put a car on it. I'd like you to use the green cars. You don't need the launchers today, and the green cars have been crashed a few less times. So you're going to get materials, a Pasco car, a green one, some stopwatches. You may have to perhaps use your phones as stopwatches if there's not enough stopwatches in the little boxes. If you need to find the stopwatches, remember, look in the back room on the shelf. You should see the two square boxes with the little red stopwatches. Tape. This is just to kind of mark where you're going to be. Pasco track. Those are on the windowsill. Please be careful of my plants. Ruler, meter stick, protractor is definitely something you want to get. 1 kilogram mass, graduate cylinder, random textbooks. Also, something else that's very useful would be a level. In the back room, I may have dumped out my little tool bin when I was getting bins for the wooden nickel trick. But levels would be very useful in terms of getting the angle, because you can hold it straight up and down. You'll know that that line is straight up and down. Very useful to use a level and a protractor together. So what are you going to do? You're going to have a car going down an incline. You're going to figure out force of gravity. Procedure. Now, don't worry about this little statement here. So place your Pasco track on the table with some textbooks to prop up one end. You should elevate the track at least 15 centimeters, but not more than 40 centimeters. You'll have to figure out just how many textbooks that's going to take. You may want to use, may borrow textbooks. If you borrow textbooks, put them back, okay? There is a supply of conceptual physics books in the next cabinet over. Put them back when you are done, please. So you're going to do more than 15 centimeters tall, less than 40 centimeters tall. There's a reason for that. Put your car on the top of the ramp. Note the spot of the front of the car, because you're going to need a distance here. Say distance travel. And you're going to want to go from the front of the car to another recording of the front of the car that's still on the track. So then time the car as it rolls down the track, stopping your watch at the very end of the track. I say the very end, perhaps a little short of the end is a good idea. It's hard to pinpoint that exact ending point. Repeat 3 times, of course, recording your data here. Average those times. Then, use time and displacement to calculate the acceleration of your car, delta x. That's why it's important to pay attention to where your car started at. 1/2 at squared times. You recorded those. Solve for a. So that acceleration that you solve for here in number 6 is going to go in this table right here. You're going to put that there. And I say you're going to put it there. Honestly, I'm going to want you guys to, you're going to use these papers not as your worksheet, but as a, you're going to write on paper for me. So you're going to get the mass. You do have to take the mass of your car. You have to get the acceleration you calculate, and you're going to calculate force using number 7 here, F equals m times a. Now for some tricky math, but it's within your ability. Measure the angle of your track that's propped up. Use a protractor at a level to figure it out. What you're going to want to do is put the protractor so that the flat part of the protractor is running along your track. Have the protractor hanging down, I recommend, so that the bottom of the protractor is even with the top of the track. Then where the 0 mark is on your protractor, put the level so it runs through there, and use the level to run directly vertical. With that being directly vertical, the straight edge of that protractor, or the straight edge of the level, will run down and show you what angle it says. Now, be smart when you read it. Obviously, you can read the protractor two ways. You're not going to have angles over 90 degrees. So when you look at my drawing, the protractor would be reading 60 degrees. So what you're going to do, because of that being 60 degrees here, that tells you, if you look at a little bit of math here, and I can explain this when I'm back a little better, and I will, but if the hill is 30 degrees, that angle would be 60. So if you're doing a little bit of trig, if this is 30, then this is 30, and this line here is what we want. This is the part of force of gravity that's pulling the car downhill. So check it out. Force of gravity is going to pull down. Part of it is pulling it downhill. Part of it is pulling the car down onto the track as well. We don't care about this one. We care about this one. Force of gravity in the x direction. To calculate that, you take mass times g, 9.81, times the sine of 30 degrees. So, angle, sine of your angle, g, 9.81, mass of your car, and then again you're going to multiply, just like this says right here, boom, f of g of x. Now, so let me scroll downward in my worksheet here. Now you need to calculate percent error between experimental force and f of g of x down here. And then of course I have questions for you, which you think is the true value, and in theory they should be the same. List 3 reasons why you think they're not the same, and then see if I can't go sideways here so you can see these questions. And then you got these questions here, and these are just some questions you're gonna answer, and then I want you to repeat the experiment twice. Once where the slope is greater than original, and once when the slope is less than original. So you're gonna either add textbooks or take away textbooks. That's why I want you to do that. Now, once you get it done once, it's really easy to roll through the experiment. Okay? I recommend taking measurements of where your books are, how tall they are, and all that jazz, because what if you need to finish the activity tomorrow? You're gonna want to have some measurements so you can duplicate it. You know, take good measurements. And please, for the love of God, take care of the cars. Okay? They do break, so please be very careful. Okay, again, you're going to take this paper that you have on the table there, and your goal, slide sideways here, your goal is to write on your own paper and save these papers for everyone to use. Alright? Good luck with your activities. And please clean up when you're done.